Hello everyone and welcome back. In this part of our game development, I would like to create the card class and then the button class. But first I have spotted some mistakes that I have done in my previous video, and this regards our backend Python file. So let's first go there, make the corrections, and then come back here in the 21 card trick Python file and continue with our classes. Okay, so let's first append to the correct lists here. So this should be row uppercase A, row uppercase B, and row uppercase C. And then we have this list here, partial list, that we are never using here. So I will just insert it inside here, partial list, and partial list, and the last one. Okay, now this function should be okay. Let's go a bit forward. Okay, here let's correct this typo. So choice and choice and choice here. Choice is equal to correct column. And now this should be okay. And we have to insert also here the correct rows. So row B, row A, row A, row B, row B, C, and A. And here row C, cards, C here again. Okay, so we fixed this part of our game now. So we can continue to create our classes. Okay, so let's start to create our card class. First, we need a list in which we are going to later store the card objects. So once we have the list, we can now go down and start to create our class. So class. So each card will have a name. We are going to use new X, new Y for the future position of the cards. So when we like to move the cards, we give the card object a future position, X and Y, and then speed. And starting from the actual position, the card is going to move toward the new position that we would like it to be in the future. So that's why you have to pass in the new coordinates. So new X and new Y. For now, we set it to 50 because we like the cards to be standing still in the top left corner, one on top of the other one. Okay, so X 50 and Y 50. And now we have to define these variables for each card. So self.name is equal to card name. So self.card name is equal to card name. Self.newX is equal to new X. and we need to do that so that in the future we can access these variables from in each card object. New X. And here we can also say self dot x is equal to x. Self.x is equal to x. X. Okay, self dot y is equal to y. Okay, add new x, put x here. And now also we have to give each of our cards an image. So self dot img is equal to Pygame dot transform dot scale, because we also want to scale the image. Game dot image dot load, and inside here we have to use the OS path join. So OS join, and we have to join the cards folder, and then the card itself. So we have the card in the cards dictionary, so cards, and we have to now to pass in the dictionary key, so which will be the card name. Okay, now here I think we are missing one bracket. Okay, and also we need to pass in the size of the card, so let's make them 100 by 133. Now that we have these variables defined, let's also define, we will need for the cards we will need two methods. One method, it will be the method that draws the card, and the second method will be the method that moves the card. So let's first start with the draw method. And self, so the card, and then we need here a window. So we need to pass in where would we like to draw the card, on which surface. So that's why when we call this draw method, we have to pass in the surface where we would like to draw the card on, and then window.blit, and the image, not it, image, and then the coordinate where we would like to draw it to. So x and then y. Not y and y, but x and y. Okay. The second method would be the card move method. So I will just type it in, and after I finish, I will explain what or how this method works. Okay, so basically this is the method, the second method that we need. So what we are doing here, okay, I'll have to move this a bit out. Okay, so if we like to remove the cards from the deck of cards and put them on a table and display them either in a row, one row, or in the three rows, then we have to pass in this method the out option. So this means that we are moving the cards from the game pack outside of the game pack. And if we would like to move the cards back in, we will pass in the in. So um, here new x and new y comes in place. We have the actual position of the card where it is located at the moment, and then we are passing in the new position where we would like to move it to. And in case, for example, the new x is greater than x, and then new y is greater than y, then we increment x and self x and self y by the speed of the card. And once the card reaches the position, the new position, so the y coordinate, the for example, the card reaches the y coordinate, but it still has to move on the x coordinate. Um, this this is done inside this if statement. And if the card has reached the x coordinate but still has to move toward the y coordinate, then this is done here in the second else if statement. And exactly opposite we are doing in the situation when we would like to move the cards back in. Okay, now we have the methods defined, we have the list, the dealt cards list defined. But what we need to do more, we need here to create the cards. So after we create a game pack, we have to fill in the list of card objects. For I in um, game pack, I equal to card and I, and then dealt cards append I. So we create four here. For each item in the game pack, for each card in the game pack, we create a card object and we append this object to the dealt cards. And now we can, having this list of card objects, we can do something with them. I mean, for example, now we can print them, or not print them, we can draw them on the screen. So we don't have to print this anymore. And we need to draw the cards now. So let's say for example here, for I in dealt cards, I got draw card. And as you remember, this method is asking for a surface where to draw the card on. So in this case, we are going to draw it on win. Okay, let's give it a try. Okay, line 53. Okay, here it's a mistake. And let's indent this a bit. Let's try it again. Line 58. X, Y. Here. Okay, again. Self card name 59. Oh, self.y. Okay, so here again we have to indent it a bit. And as you can see, the cards get drawn one by one in the deck of cards. But now if we stop it and we modify that frames per second to 60 and we run it again, you can still see that it's because this is every time a new game pack being drawn. Okay, but we do not want a new game pack every time we call the redraw function. So we have to call game pack here, and we can remove it from here. And later on, when we would like to restart the game, we can call it again and get a new game pack. Okay, if you right now you can see that the game pack is standing still. There is no more refreshing of the game pack. It's only one. You cannot see all the cards, but they are all here, drawn one on top of the other one. Now that we have the card class created and we can display the cards on the screen, I would like to create a few functions that will allow us to move the cards on the screen. Okay, so let's start here underneath this class. And the first function that I'm going to create, it will be called cards display pack. And this function will display the cards in the pack as we have them when the game started. And now we have to use the global variables. So global del cards. And now we have to create one more variable that is going to hold the direction of the cards. And we need to make this variable global so we can access it from different parts of our code. So I will just go on top, and underneath this list I will say card direction, or short dir is equal to nothing for now. And here cards dir not cards card direction. Okay, so when we want the cards to go back into the pack, the direction should be in. So card direction is equal to in. And now we have to give all the cards the new position. So it does not matter where they are on the screen at the moment. We are going to tell them just go in the position X50 and then Y50. So let's do that in a for loop. New X is equal to 50. And then I new Y is equal to 50. Okay, so this is the function that is replacing the cards back into the pack. The next function that I would like to create is the function that displays the cards on the table in one row. Okay, so let's start creating that function. Cards display. And we need again this global variables. Card direction. And this time card direction will be out. So we are moving the cards from the pack out on the table. And we need now to increment a bit the x coordinate so that the cards will not overlay. So we will just start by, I'll just create here another variable called x card. So this means this is the position on the x axis for the cards. Let's say x cards is equal to 110. And now in a for loop, we are going to assign the cards, all the cards, the new coordinates. So if and only if the cards are in the docked position in the pack, not if they are in some other position. That's why we are inserting here an if condition. New I will be the same for all the cards because we need them on the single row, but then we need to modify the X for each card. So that's why outside of this if statement, I will increment the X cards by 40. Okay, so this is the second function that we need for the cards. Now we need another function that is going to display the cards in 3 rows. Let's call this cards row display, or better, display by rows. And we need again the same global del cards. So global dealt cards and cards direction. And the direction of the cards will be again out, because the cards initially will be in the pack and then going out from the pack. And we need here a counter, X position, starting X position of the cards and starting Y position of the cards. And then we have to increment the counter and also X position and Y position. So let's do that. And as I said, we are going to display them in 3 rows of 7 cards. So if I forgot to define a counter here. So if del cards counter, so if their position is 50 by 50, so they are in the deck of cards, then we do this. Otherwise, we are not going to do it. If they are located somewhere else on the table. So send them counter, and we give here a new position where we like the card to go to. New Y. and we increment the counters for the next card here. So counter plus plus plus. We increment the X position for the next card by 100. So the next card will be on the right side of the previous one. So here outside of the second for loop, we are going to reset the start X position to 280. Because we want the second row to start from the same X position, but we like it to start lower than the first row. So we have to increment start Y by 150. Start Y. Okay, so now we have 3 functions already defined. The last function that we have to define is the one which will allow us to display the result. So when we have the last card that we have to display, which is the correct card, and the game is at the end of the game, then we need this function. So let's create this one as well. And display. And we need again, it's going to move out of the card pack. Is going to, we are going to need this del cards and card direction variables. And now let's write it. So underneath here, cards. We know that at the end, the 11th card from our pack will be the correct answer. So scale. OS path join. So what we like to do first, we would like to load the back of the card so that when we move the card on the screen, initially the card will not be shown. Just simulate that the card is turned upside down. So that's why here we would like to load the back of the card and move this card on the table. And once we finish moving it, after a couple of seconds, turn it over and display the result. Okay, so image, and now we need to join card. It was called, what did we call this? Cards folder. And then we need to also specify the name of the image, and that is purple underscore back purple back.png. And here, of course, we have to also give it the dimensions of the card. That was 100 by 133. And I think that it would be a good idea just to put these values inside a variable underneath. Let's call it here, or better, where do we have the dimensions of the, maybe here. So card and capital, because we are not going to change this, width, and then card height is equal to 100 by 133. And now we can use this here. Card width, card height, and even here as well. Card width and then card height. Okay. Yeah, and now we have to give this card the coordinate where we like it to move to. So del cards and then the 10th card, the 11th card, and now new X. Let's move it to the. Let's try to move it in the center of the screen. 10 and then new Y. Okay. Now we are done with the functions that move our cards. We can now test how these functions work, and we will write a bit of code here that we are going to later on remove. But let's just say here under this for loop keys. So what I'm trying to do now, I'm trying to pick, I'm trying to use the keys from the keyboard to do something for us, to move the cards. So to do that, I have to get all the keys that have been pressed. So we can do that by saying keys equal to pygame dot key dot get pressed, and now we assign this the list of the keys that get pressed to this variable key. And now let's check if, for example, if the space key was pressed, if A key was pressed, and if B key was pressed, and do something about that. So let's do it here. If keys, or if key, okay, let's start with space underscore space. Okay, let's print space. Okay, and we do exactly the same for the other keys. Okay, A, print A was pressed. And the last one, I just copy this. And let's keep B. B was pressed. Okay, if we try to run it now, invalid syntax counter plus plus line 123. Come on, okay. Sorry, it was from Java. Okay, try it again. Okay, so now we have again the pack. Let's try to press. I will press now. I will just move this a bit up, and I will press the A key. So A was pressed, and then B key. B was pressed, and then let's try space key, and space was pressed. So this is working. And let's connect these key presses to our functions, and we can start to move the cards on our screen. So here, instead of printing this, let's just call cards display, and next one, let's call here cards display back, and the last one, cards display by rows. Okay, let's see if it's working. So if I press now, nothing is happening. I can press A, I can press B, I can press space, nothing is happening. That is because we have to call the cards move method from inside the cards class for each card. And we also have to specify speed of the card. So the speed with which we like the cards to move. So let's say here cards and speed. I'll make this one equal to 5. And underneath here, not here, but here. Actually, I have to define this in some other place underneath here. So underneath frames per second, I will say card speed equal to 5, and underneath the draw card for loop, I will also define another for loop for j in delt cards, j dot card move, and we need here to specify the card speed and then card direction. So for the speed, we are going to use cards speed and then card direction. And now let's try it again. So the game started. If I press A, no, B, and we have the okay, here we have a problem. Line 80, because this should be a lowercase y. Let's try again. Okay, so the cards are moving and they are displayed in 3 rows. And now I will shift them back. I pressed A and now they are going back. Okay, let's display them in a one row. Okay, and as you see now we have them in 1 row. Okay, so this video is dragging on quite a lot now. I will stop it now, and in the next one I'm going to create the button class and all the other remaining functions to finish our game. So thank you very much and see you in the next one. Bye.